This conference will now be recorded.
All right, so this is the video for 2.4 to get us started and keep us kind of on track for when we get back together this week. So this is about the product and the quotient rules. Before we learned that we could only take derivatives of polynomials because they were pretty much just applications of the general power rule that we learned. And it was because everything was being added or subtracted together, so we were able to just take each piece individually and take a derivative of it. Well, now we're going to have a little bit of a problem because we're going to be looking at functions that are combinations of functions that are a little bit more difficult to figure out the derivative of. In other words, what happens if you have two different functions that you're multiplying together or two different functions that you're dividing? And the problem or the issue here is that sometimes you can actually just FOIL stuff out and you can take a derivative like normal. But sometimes we're going to be involving more complicated functions like a square root of x and an e to the x. And you can't multiply those two functions together. So we have to have a rule for how to take those derivatives. So the way and the kind of the reasoning behind this one, I do not want to give you a full proof because this is not what this class is about. But if you think about just an area of a rectangle and think about F being the length and G being the width, if you could change one side of the rectangle, so say you could increase or decrease this length as much as you wanted, then we could talk about how there'd be a change in the length and change of F. So we could kind of talk about derivatives in that way that we have when we talked about instantaneous rate of change. So this formula comes from considering what happens, and this is, like I said, very simplistic explanation. What happens if one side changes but the other one kind of doesn't? So that's your two conditions here. So look right here, this is the derivative of f times g being stationary plus f times the derivative of g. So notice in each scenario, we're considering kind of that change in one side of the rectangle. So see how G could have changed here. So think of that as being change in G, this is change in F. So again, I'm not doing any of the limit proof here, but that's kind of how you visualize this formula. So the derivative of the product of two differentiable functions is equal to the derivative of the first function times the second, plus the first function times the derivative of the second. Some people will mix up the orders on these, like they won't put the f prime as the very first thing you do. You have to be careful with that because the same pattern is going to apply into the quotient rule in a minute, and it will matter because there's a negative sign. So it's better to kind of get the pattern down correctly so that you're using it correctly. So the way I do this, and again, I'm going to show you two simple examples that I actually could have just distributed out and did a regular sum and difference derivative of. But I want you to see how this works out when you're doing the product rule. So the first thing you want to do is you want to label each of these functions as, f and g. And sometimes we don't use f and g because if your original function is already called f, like number 2, I'd like to use h and g. I try to use a different naming system. So this one's going to be f of x, and the other one's going to be g of x. And hang on, my pen just froze. So I'm going to call this one f of x, this one g of x. And let's write down a couple things. And this is how I choose to write it. It helps me with the formula a little bit. So I always write f of x and then g of x. So this is 3x minus 2x squared. This one is 5 plus 4x. Across from f, I do f prime. So this would be 3 minus 4x using our just regular power rule that we've learned. And g prime is going to be 5 gives me nothing, but 4x gives me just a 4. Okay, so the way that the formula is easy to memorize if you've written it in this specific order is that you're kind of doing diagonals. So you take this one as your first diagonal, and then this one is your second diagonal. Okay? So you're kind of going from top to bottom, and you go start from the top right down to the left. So we're doing f prime, so look up here, here's our formula. So the derivative of y is f prime, which is 3 minus 4x, times g of x, which is 5 plus 4x, plus, because that's the separation between our formula, And then f of x is 3x minus 2x squared. And g prime of x is 4. Now you'll have to work all of this out, so we need to FOIL or distribute anything we see. So this is going to be 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. We'll combine any like terms, so negative 16 and negative 8 is negative 24x squared. We have a 12x and another 12x, that's 24x, minus the 20 would be positive 4x, and I have a plus 15. So there's my derivative. Now I use the product rule to do this, but I want to show you that this is an easy one. I could have distributed this all out first and then just taken a derivative. So I want to show you that we do get the same answer. So if we'd done that, so this is kind of just a little side note to show you that the formula actually works for this one. If we distributed that out, that would be 15x plus 12x squared minus 10x squared, and then minus 8x cubed. If we took a derivative of each of those, that would be a 15 plus a 24x minus a 20x minus a 24x squared. And you combine like terms and you do get this. So the thing is, I want you to realize that the product rule is not here to make your life worse. It's that eventually we're going to see some different function combinations that you really can't do any of the foiling or distributing to make it easier. So you have to have the product rule in place then. But I wanted to verify for you that it does give us the same answer. So let's do another one. Let me see if I want to do one that's a little more interesting on the video. Maybe I will do number 3. So let's, and this is already called G. So when that happens to me, I let the first function be F just like normal, but I'll call the second one H. And that's just so that I don't see multiple G's when I'm writing my final answer. So F of X is 3 minus X. The derivative of that would just be -1 because the 3 gives me nothing and a 1 would come to the front here. It's times -1 and then you get x to the 0. H of x is going to be, no, I probably want to bring that to the front. That's 4x to the -2 minus 5. Sometimes rewriting that helps. So it is 4 over x squared minus 5 as an original function. I'm going to look up here for the derivative. That would be -8 x to the -3. So that's going to be in the bottom. And then minus 5 gives me nothing. So again, remember top down is 1. So from the right down to the left. And then from the left down to the right is 2. So g prime of x in this scenario would be -1 times 4x squared minus 5 plus 3 minus x times -8 over x to the third. I want to distribute everything out. So this is -4 over x squared. So -4 over x squared. -1 times -5 is +5. Then I get, that's going to be -24 over x to the third. And then this is going to be, one of those x's will cancel, so that's going to be +8 over x squared for that last term. And then when we combine our like terms, I'm going to put these, it doesn't really matter which order, but I'm going to put -27 over x to the third. I can combine the two that have the same denominator, that's 4 over x squared, and then plus 5. So again, this is using the product rule. Let's try one more of these because I believe, yeah, after that we'll have some applications in class. I'll still do maybe 1 or 2 of these in class with you. Let's look at this one. So this is already called F, so I'm going to call this one H and this one G. So H of t is t to the 4th minus 5t. So that means H prime of t would be 4t cubed minus 5. G of t is 3t to the third plus 8t minus 7. So g prime of t is 9t squared plus 8. Again, just using the power rule for each of those groups. So then remember, top right down is 1, top left down to the other side is 2. So my f prime of t using our product rule is 4t cubed minus 5 times the 3t cubed plus 8t minus 7 plus t to the fourth minus 5t times 9t squared plus 8. Now this is the ones where the polynomials are not as fun to do because you get a lot of distributive property here. So 4t cubed times 3t cubed is 12t to the sixth. 4t cubed times 8t is 32t to the fourth. 4t cubed times negative 7 is negative 28t cubed. Negative 5 times 3t cubed is negative 15t cubed. Negative 5 times 8t is negative 40t. Negative 5 times negative 7 is positive 35. T to the fourth times 9t squared is 9t to the sixth. T to the fourth times 8 is 8t to the fourth. I get a negative 45t to the third and a negative 40t. So in this scenario, it really would have been more beneficial to have just distributed it out at the beginning and done the power rule, but we want to show you that the product rule still works. So 12t to the sixth and 9t to the sixth, that would be 21t to the sixth. There's no t to the fifths. For fours, there's a 32 and an 8. That would be 40t to the fourth. For cubes, I'm going to need my calculator just to double check. I have a 28 that's negative plus a 15 that is negative, and a negative 45. So that's negative 88 t to the third. I don't see any t squareds, and there's negative 80t. I don't believe, yes I did have one constant, so plus 35. So there is my derivative using the product rule. So we've shown you a couple different varieties. We'll do the tangent evaluation on that when we get into class next time. And I'll also do these evaluations where there are numbers, so don't worry about those yet. So let's talk about the quotient rule. The quotient rule is, again, you can think of it like an area problem, but remember a quotient is f over g. So what they like to do is they like to think of it as f times 1 over g. And again, this is just kind of generic, so you can kind of think through how the formula came about. So the reason that this one ends up interesting is because you get your derivative when f is changing. When g is changing, it's not g, 1 over g. So you actually have to consider the derivative of what 1 over g is. That's g to the negative 1. So if you take the derivative of that, and we're kind of using symbols here, so don't take this as literal, because you really do have to consider limits. You would have that negative 1 would come to the front, and this is kind of something we haven't talked about yet because there would be a chain rule, of course, attached to this since it's a function. But we just want to get an idea of where the formula came from, and then that would be negative 2. So that's negative 1 over g squared. So notice you still get the f prime times g and the f times g prime. But because you have a negative sign on this guy's derivative, the g's derivative, you're getting a minus sign in between the two. And then this g squared is showing up in the denominator. So this is, again, crude, not the official proof, but it's one way that you can try to understand how the formula existed. So the derivative of a quotient of two differentiable functions is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. There's like a little like high d low and then low d high, something about all over the low squared. I'll tell you what that is in class. There's like a little mnemonic device you can use to memorize this. I learned it in calculus and then I forgot it. But if it helps you, I'll give you guys that in class, but this is pretty much the formula. I attack this the same way that I do my product rule. I list out all of the different derivatives and the original functions, and then I just plug it into the formula in its places. So notice this is a problem for us. This one specifically is one where we can't split this up into a polynomial. We only can split a fraction into a polynomial if each thing is being divided by a monomial, and this is a binomial in the bottom. So this is actually the only way we know how to do these, is to do it by the quotient rule. So we're going to take, now again, there is a chain rule application if you think about what we did with the rectangle up there, but we haven't even learned the chain rule yet. So for us, this is the best method. So we're going to list this as f of x is the top function and g of x is the bottom function. So it's going to be f of x is x minus 1. The derivative of that would just be 1. G of x is 2x plus 3. So we're starting off pretty easy. G prime of x, the derivative is just 2. It's your same diagonal that you just drew before, 1 and then 2. The only thing is we're subtracting when we do the quotient rule. So 1 times 2x plus 3 minus x minus 1 times 2, and then it's always over the bottom, the 1 squared. So 2x plus 3 squared. You want to work out the top. So this is our y prime. So this is going to be 2x plus 3 minus 2x plus 2 all over 2x plus 3 squared. So that's the 2x's on top cancel out, so it's actually just 5 over 2x plus 3 squared. So there's y prime. So again, this would be really difficult to try to do with the limit definition, so this formula saves us a lot of grief. Okay, let's try another one. Let's try number 3. I'm kind of leaving the evens open for us. So then when we do the, this one's already called F, so I'm going to call the top H and the bottom G. I like to keep the one that if this is F, I like to keep the G as its normal location. So H of X is 2x squared minus 4x plus 7. H prime of X would then be 4x minus 4. G of X is 6x minus 1. And G prime of X is just 6. Okay, so then remember our first diagonal goes from the right down, and then from the left down is our second diagonal. So this is 4x minus 4 times 6x minus 1, and since it's the quotient rule, we subtract. 2x squared minus 4x plus 7 times 6 all over my denominator squared. So we FOIL out what we have on top. So this is our f prime of x here. So f prime of x is 24x squared minus 4x minus 24x plus 4. You'll want to be careful here. Make sure you realize you're really distributing a negative 6. So that's negative 12x squared plus 24x and then minus 42. Sorry, my computer's lagging a little bit tonight. There we go. So minus 42. All over that 6x minus 1 squared. Okay, so then let's clean this up. On top, that's 24 minus 12 for the x squared, so that's going to be 12x squared. We have a negative 4 and a negative 24 and a positive 24x. The negative and positive 24x cancel each other out, so that's just negative 4x. And then I have a 4 and a negative 42, so that's going to be negative 38. And then 6x minus 1 squared. Now typically you would need to check to see if that top factors, because would it possibly cancel with 6x minus 1? It's highly doubtful that the factor of 38, that's going to be the one that we use as a 1, even though it could be a 6 for the 12. I just don't see that foiling out, but you would want to check over on the side. Okay, so I think that's a good place to stop. because a lot of these are just practice writing the equation of the tangent line, which we'll do together. I might do 5 real quick. It's not too bad. That way we've done all of the odds on this part. So we're going to call this f of x and g of x. And this would be f of x is x squared. G of x is, or excuse me, f prime of x. So f prime of x is 2x. G of x is x minus 8. So g prime is 1. So I have 2x times x minus 8 minus x squared times 1 all over the x minus 8. That's going to be our y prime using our quotient rule. So this is 2x squared minus 16x minus x squared over x minus 8. That is x squared. I have no idea what just happened there. My screen went black. Oh no. Well, that's never fun when that happens. Let's see if it saved my work. No, it did not, but that's okay. I'll redo this one real quick. It's an easy one. So we said f of x was x squared. F prime of x is 2x. G of x is x minus 8. G prime of x is 1. So we had 2x times x minus 8 minus x squared times 1 all over x minus 8 squared. And I had 2x squared minus 16x minus x squared over x minus 8 squared. That is just x squared minus 16x over x minus 8 squared. You could factor an x out of the top. That does, at least work, but it doesn't cancel with anything in the bottom, so it's not necessary. You could just circle this. So either one of these is acceptable since it doesn't reduce. All right, that's a good place for us to stop this video, and we'll do a few more, each of product and quotient rule, and that will then allow us to jump into the chain rule next time after that. So have a good rest of your weekend, and I'll see you guys all on Tuesday.